All right, hello, we are ready for Geometry Notes 4.2 called Angle Relationships in Triangles. Now remember this chapter that we are on is all about triangles. So our code word, we haven't done a code word for a while, would be triangle. If you would, at the very bottom of the paper, write the word triangle. That's your code word. First theorem here, 421, triangle sum theorem. The sum of the angle measures of a triangle is 180 degrees. In other words, if you were to take these three angles, angle A, angle B, and angle C, they would always add up to 180. You need to know that and to memorize that. Some more theorems, they're called corollaries. And corollary is a theorem whose proof follows directly from another theorem. So it's kind of like a follow-up of a previous theorem. Here are two corollaries to the triangle sum theory. Not thumb, but sum, sorry. 422. The acute angles of a right triangle are complementary. In other words, we know right here angle F is 90. That means that D and F added together make the other 90, because 90 and 90 is my 180. So the other two angles in a right triangle add up to 90, which means complementary. The theorem at the bottom, 423. The measure of each angle of an equal angular triangle is 60. Now remember this word, equal angular means that all three angles are congruent, which means these angles have to be 60, because 60 plus 60 plus 60 is the 180. Well, with that said, here's an example. One of the acute angles in a right triangle measures 2x. Let's draw that. Let's draw a right triangle. One of the angles is 2x. What is the measure of the other acute angle? Well, remember, since this one's 90, the other two have to be 90. So let's just call that x. That means that 2x plus x, those other two angles, have to add up to 90. Well, some algebra tells me that 3x would equal 90 divided by 3, so x is 30. That means that this angle is 30 degrees, and twice that, 2x, would have to be 60 degrees. So 90, 60, and 30 would be my three angles. Look at the next one. This one reads, the measure of one of the acute angles in a right triangle is 63.7. Let's draw this. Right triangle. Let's say, just pick one. 63.7 is that one. The question is, what is the measure of the other acute angle? Let's call that x. Well, that means that x plus 63.7 would be 90. So if I subtract those, that's what, 26.3? So that means this angle up here would be 26.3 degrees, because the other two angles add up to 90. Let's move on. Some more definitions here. Interior and exterior. The interior is the set of all points inside the figure. The exterior is a set of all points outside the figure. Kind of intuitively obvious. There's interior, exterior. Let's talk about interior, exterior angles. An interior angle is formed by two sides of a triangle. Hello, Mr. Webb. An exterior angle is formed by one side of the triangle and an extension of an adjacent side. I'm losing track here. Mr. Webb just came in my room, so Great. Thank you, Mr. Webb. That's my code for the day.
Hello.
He says hello. Where was I? Let me start over here. An interior angle is formed by two sides of a triangle. An exterior angle is formed by one side of the triangle and an extension of an adjacent side. Okay, so your interior angles are this one, this two, and that three. Angle 4 is an exterior angle because we've extended, oops, I don't want that. We've extended this side. We've extended that side of the triangle to make angle 4. So again, angles 1, 2, and 3 are interior. Angle 4 is exterior. Well, seems pretty obvious because that has to do with, let me get to where I need to go. It has to do with this theorem. It's called the exterior angle theorem, 424, which reads, the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Now look at the pattern here. Angle 4 is equal to 1 and 2. So this angle 4 is on the outside. It equals to these other interior angles, which we call remote. So they're the ones away from it. We would add those two together. That would always equal angle 4. With that said, how about this example? Find the measure of angle B. Well, this 5x plus 60 right here is this angle right here. That's my exterior one. So I'm going to write 5x minus 60 would equal the other two remote ones opposite away. So it's the 2x plus 3 plus the 15. So the exterior angle equals the other two interior angles. So let's solve this. It's going to be 5x minus 60 equals 2x plus, let's combine those to make 18. I would say subtract 2x to give me 3x over here. Minus 60 is 18. Let's see, add 60. So 3x is 78. And then divide by 3, that's what? 20 and 1, 29. No, 26, sorry. 26, my fault. But that's not my answer. I need to plug that answer in because I'm asked to find the measure of angle B, which angle B up there in the diagram is 2x plus 3. So I need to substitute in 2 times 26 plus 3. Can't forget this last step. So that's what? 52 plus 3, 55. And 55 degrees would be the answer I'm looking for. Okay. One more theorem and 2 more examples, then we're done. This last one is called the third angles theorem. And it reads, if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third pair of angles are congruent. In other words, if the first 2 angles are congruent to each other, then we can assume the third angle is also congruent to each other. I'll say it again. If the first 2 angles are congruent, then the third angle is also congruent. If you look at this diagram on the next to last example, these arc marks, I have those 2 angles congruent, and I have these 2 angles congruent. So I have the first 2 angles congruent, so I can assume that the other 2 angles are congruent. So I could write 4y squared equals 6y squared minus 40. Well, solving that, I would subtract 6y squared to get a negative 2y squared is negative 40. Negative 40. Divide by negative 2, so y squared is 20. In other words, y is the square root of 20, and we can put that into a decimal if we wanted to. But I'm not quite done because I need to find these angles. Let's find the first one. 4y squared would be 4 times the square root of 20 squared, which is just 4 times 20, or 80. Because when you square a square root, it just becomes the 20. The next one would be 6y squared minus 40. So in other words, that's 6 times the square root of 20 squared minus 40, or 6 times just a regular 20 minus 40. That would be 120 minus 40, which is 80. I get 80 for the first one and 80 for the second one, which is supposed to happen because those two third angles are congruent. One more. This one's the same thing. If you look at how the triangles are marked, angle M and angle R are congruent, and angle N and angle S are congruent. That means the third angles would be congruent. So I can write 2x squared equals 4x squared minus 32. Subtract 4x squared, so negative 2x squared equals negative 32. Or divided by negative 2, x squared is 16. Take the square root of 16, so x is 4. Now plug that 4 back in. Don't stop with that answer of 4. Into angle P, 2x squared, I need 2 times 4 squared, or 2 times 16, which is 32. Let's do angle T, which is 4x squared minus 32. Plug that 4 in, so 4 times 4 squared minus 32 is 4 times 16 minus 32, or 64 minus 32, which is an answer of 32. And notice in the blue and the green, those two numbers are the same, and that's supposed to happen because they're my third angles. Hey, thanks for watching. Code word here was triangle. If you would please put an X through that triangle. Just mark an X through the word triangle there at the bottom of your paper. That's my code word. Hey, thanks for watching.